Welcome to the AgEmerge Podcast, brought to you by Ag Solutions Network. Your farming challenges are unique, so your practices should be too. We're here to share emerging ideas, build connections, and provoke conversation.
Get ready to improve your soil, your crops, your livestock, and your family's livelihood. I'm your producer, Kim Chase.
And I'm your host, Monte. Thanks for joining us.
Thanks for joining us. Today we welcome Dr. Dianna Bagnall, a research soil scientist for the Soil Health Institute. Her current work includes integrating research and outreach to secure the global soil resource. Some of her specific research includes developing functions that show the effects of management on soil physical properties, also on-farm soil health assessments, qualitative analysis of farmer interviews, and outreach to farmers in the United States. She and Monte discuss the importance of being able to quantify and assess these practices that are being used to build soil health across the country. Let's get started with this powerful conversation.
Welcome, everyone, to this episode of the AgEmerge Podcast. I'm pleased to be joined by Dr. Dianna Bagnall. Welcome. How are you today?
I'm fantastic. I'm really excited to be here with you all.
Well, it's pretty neat what all she's been up to, but I'm going to let her tell her story. I want to give us a little bit of your background and really your why. How did you get involved and interested in what you're doing here today?
Yeah, great question. Well, I started out interested in agriculture, back as a 4-H kid. I grew up in Texas and, got to learn a lot about plants and animals. And I ended up going to a junior college where I had the chance to work in a little bit of soil science and really fell in love with it. I went on to Texas A&M University and worked there for a little while. And then I got, this academic thing is all right, but I think I'll go work for a bit. And I was a project manager for several years there at Texas A&M. And that was such a great job for me because I got to really see how the knowledge that scientists work on goes out to corporations and nonprofits and the government and the real world. And I became really passionate about understanding more of that. How do we take our science and really get it to the folks who are going to use it? So I went back to school and I got an interdisciplinary PhD. I studied natural resource economics, soil physics, and also a little rural sociology. So I get bored very easily is what I tell folks. And then in 2019, when I graduated, I had the opportunity to come work for the Soil Health Institute in this nonprofit space where I'm a research scientist now. And I was just so fortunate to get to do all that interdisciplinary piece and really the applied science that we do at SHI.
So you mean they allow you to study in more than one silo? I didn't think that was allowed by law.
It can be hard. You really have to work at it. But it's great. And I think it's something that more and more we see, folks thinking in that how do we work across these boundaries and these barriers to deal with real world problems?
So tell us a little more about that as far as, your choice to do that. But then from your perspective, what you see those silos that are out there that are just set up by its nature in education. And it's heartening that others are looking at, crossing the silos and such. But talk about that experience for farmers and listeners, what that's like and what kind of challenges. I mean, it's good in certain spots, but it's not good for other reasons. So talk your opinion on that.
Yeah, that's a great question. I think that sometimes the challenge for being in an interdisciplinary or a transdisciplinary space is that, you have to be kind of good enough at some core competency to be able to market yourself really well and convince folks that, you've got this subject matter expertise. But and I think that's really important. And so sometimes it can be more work. And I think that our growers and folks know that. They know that when you're learning something that's maybe a little bit outside of the way that you've done things, maybe even when you're doing something that's outside of the way that everybody, maybe in your county has done things or your state has done things, there's challenges there. But I was really impressed years ago reading some material where this gentleman who had studied in electrical engineering, he'd studied in aerospace, he'd studied in a lot of different spaces, and it just showed how quickly this individual was able to diagnose problems because the understanding of both the electrical and the chemical and the physical systems were all kind of in one person's brain. And as a student, I really took that to heart in interdisciplinary science, that it was my job to have enough economic knowledge, enough soil science knowledge, enough sociology knowledge kind of live in me to be able to put those things together. Truly being interdisciplinary is not you talking about your stuff and me talking about my stuff and us talking past each other. At least a little bit of it has to live in both of our minds. So we both walk away with a bit of that knowledge in us.
So you had to know more than just to be dangerous, is what you're saying.
Yeah,
had to be functional. But no, I think my biggest challenge is with being interdisciplinary is spelling that and not having autocorrect mess it up for me.
Well, that is what autocorrect is for, as far as I'm concerned.
So that's interesting. And in I think being able to see the multiple things, especially the sociology component that you got in there, because I don't believe people understand how hard it is to affect change because of social norms, peer pressure, all those dynamics within sociology. So dive into that discipline a little bit for us.
Oh gosh. Well, I think, as a scientist, I would say a lot of our problems end up being, they're about our choices, ultimately. There's a lot of information out there right now about exactly how healthy I could be and all the ways I could be absolutely the healthiest, but it's really going to come down to the choices that I make. And when we talk about our soil health and we talk about, that there's a piece there, we believe at the Soil Health Institute that really centers around the adoption decision, that our producers, our folks out there really working the land who understand their systems. It's their choices. And we have an obligation to kind of support that and to make sure that we're taking, our fair share of the benefits that they're providing to us as they're giving us, food and clean water and clean air and so many other things. So I can see that, and I think that ultimately we have to have solutions that work for real people in real places. So that sociology component, as you said, so critical, that all our problems are people problems when we come right down to it.
Well, there's never a people problem until there's two people. So I like what you said there. In my mind, the way I summarized it here was just, it's not really a lack of information today. At 10 years ago, there kind of was, right? And adopting cover crops and no-till, what those impacts could be. We've got that information. Now it's the decision thing, and what you're saying about the health. I know everything chemistry-wise, componentry-wise, everything I need to do to be, a strong 180-pound guy. But here I am, I'm not, right? So it's not a matter of knowledge, it's a matter of behavior. So it's getting that adoption decision, as you said, to enact. So then along comes Soil Health Institute, which this is a unique organization, right? So it's unique in the fact that it's nonprofit, but it's research. And how this all works. Describe your experience with Soil Health Institute and some of the amazing things that you've got going on there.
Sure. Well, there's a lot of ground to cover there.
Yes.
I would say, so we're a 501c3 nonprofit, as you said, and our mission is to safeguard, enhance the vitality and productivity of soil. And if that sounds like a really big job, it is a really big job. It's, there's a lot of components, but we approach it systematically. We center our work around that adoption decision of producers and ask, what's the information that growers would need to make this decision? And, they tell us they need to understand the business case for soil health. They need to understand locally what's the right way to measure their soil health and how do they make those measurements meaningful, interpreting. And I can tell you right now, you got an aggregate stability of 0.8 and doesn't maybe mean a whole lot. Yeah, yay, have a party. And I think that, so we worked in that economic space where I think over 150 partial budget economic interviews. We've done corn and soy in the Midwest. We're working on a lot of cotton production now, really understanding what are the benefits that those growers are seeing, that they're seeing reduced costs when they reduce their tillage, that they're seeing ability to cycle nutrients better. And so they've got reduced inputs, reduced diesel fuel usage, all those kinds of things, and a lot of different systems. We're thinking about that measurement piece. So we've done a lot of work to really have peer-reviewed literature that supports a minimum suite of soil health indicators so that we don't have to go out and measure 57 things to try to understand how healthy our soil can be. But in most situations, we can use just 3 or 4 indicators and tell you, that's just about how healthy your soil is. And a lot of our work now is really in a space of trying to contextualize that. Use the example of, hey, how about 0.8? Is that good or bad? But if I told you that, the best grower in your area was at 0.9 and that maybe a perennial native prairie was at 1, then you might have some more context to understand how healthy your soil is and how healthy your soil can be. And so those are some of the activities we have, in this space of informing that adoption decision. We do research, as you mentioned, in space where we think, we need a better measurement technology here. We need a model that's more clear. And then we're also really thinking about assessing those impacts, understanding how we can perhaps inform policy, inform people in the supply chain. I think increasingly we see the supply chain asking, what's the soil health on which the supplies that we're purchasing are grown? And so we see a lot of interest there. So both thinking about the adoption decision, thinking about informing it, working on research, and then understanding those impacts that can cycle and pull market demand to provide, more economic incentive for growers to be supported in using these practices, like reducing their tillage and using cover crops that are really going to support society and the environment.
And defining soil health has just been a real hard thing to do, right? At the very beginning. But I like how you said that you've come to where, did I hear you right? Like 4 parameters that really narrow in on that catch the lion's share of it. It's not going to every little nuance that there is, but you can look at some certain things and just know, hey, you're headed in the right direction, or you can have some, in your example of comparing and such. What do you think are the things that are most important to look at to define soil health in those parameters?
Yeah, so
bulk density or aggregate stability, excuse me.
Yeah, no, absolutely. I think so. There's several pieces there. We have a definition that the NRCS has put out for soil health, which is that it's the continued capacity of a soil to function as a vital living ecosystem. Well, that's really helpful in understanding what it is. And we take the approach of looking at principles of soil health. So we know that we are going to want to reduce our physical disturbance. We know that we're going to want to keep our soil covered and increase our biodiversity and things like that, keep our living roots as much as we can in the year. Maybe even look at some integration of livestock if we have the opportunity to do that. And so those principles apply in different combinations in the same way that I might say exercise is a principle and nutrition is a principle. And then the question is, what are the measurements, to your point, that we're going to look at? And we have a lot of information out there on our website and our recommended measures page where we talk about the indicators we've recommended. And we've done that based on looking at 124 different long-term research sites across the continent, so US, Mexico, and Canada. And so each of those sites had individual experiments and trials that included the effects of soil health management. And then we looked across them as well. So with that really huge data set where we went out and were able to collect in partnership with a lot of other institutions, we found that when we measure the soil organic carbon concentration, the aggregate stability, and we actually now that can be done on a smartphone. We don't have to send it off to the lab. Looking at aggregate stability, looking at the potential carbon mineralization. Some of your listeners may be familiar with soil respiration as another way to say that. And then we're able to use that information, that soil organic carbon, plus knowing the soil sand and clay content that oftentimes we have for maybe our fertility tests, and we can predict the plant available water holding capacity. So that's that 4th indicator. So carbon, aggregate stability, potential carbon mineralization, and the plant available water are the indicators that we think in just about all the cases that we run across, we can see change in one of these in response to adopting those soil health principles and then thinking about practices that really work for us locally.
Okay, now back up. You lost me at the whole, this is available for your phone measurement. And I'm, whoa. I've missed out on something. Dive into that. How does that work? I mean, we can do everything on our phone now.
That's right.
Not just start our car. We can look at our soil. Tell me more about that.
For sure. So when we think about the different ways to measure soil, and I'm a soil physicist by training, so I think a lot about those physical parameters, and our growers know their soil structure, their aggregates, when they improve their soil health, are getting stronger and they're getting more resistant to degradation. And so there was work out of the University of Sydney in Australia that was able to use photography to say, if we took these little aggregates and we put them in a petri dish of water, and we see how long it takes them to expand and how much they expand as they are kind of like they slake out with that water, that we're able to use that and say, well, this is a pretty good measure of how stable those aggregates are. And so there's a phone application that the University of Sydney put out, and we're working on a second version that we hope is out later this year. But we are able to use that technology to be able to measure aggregate stability. And we do have some more information on how laboratories can use that at our website. So labs that are interested in adopting that have a standard operating procedure that they can go take a look at. So yeah, I think it really shows the advancement and the idea that more and more will have soil health assessments that really make sense for individuals out there.
The AgEmerge Podcast is brought to you by Ag Solutions Network. The ASN team is hands-on, digging in and invested in regenerative agriculture. Along with the proper plant nutrition and biologicals to boost your soil microbiome, we provide the ideas and implementation guidance to support you on your soil health journey. So stop farming the same way and contact Ag Solutions Network today at asn.farm.
So yeah, that's fascinating that work's being done. I think that's another great role that the Soil Health Institute has done, is pulling all these information articles together. We don't need to reinvent the wheel. We just need to look at where are all the wheels, right? First off, and I'm holding back because I really want to get to this the topic on the comment farm tool, but I'm trying to not jump to the best part. Okay, but well, let's go there anyway. I think this is a great tool. And in regards to article and pass, walk us through there. And I want to dive into that a little bit. This using research and doing, to me, it appears to be multiple studies put together into a tool that a farmer can then show him or herself by making a certain practice change. I have the ability to influence the total water holding capacity in my farm. So walk us through that, and I really appreciated the video that you did, and we'll include that video link in the notes too.
Sure, absolutely. So the study I was talking about earlier, where we looked at 24 different research sites, long term, so 10 or more years, and the professionals were kind of monitoring these, that gave us this huge data set where we measured more than 30 different soil health indicators at each of those 124 sites. And there were many great things that came out of that data set, including what we've already talked about with a minimum set of indicators. Another thing that brought us was the ability to understand, really for the first time, how when we increase our soil organic carbon, how much more water does our soil hold? Now, I say for the first time. There are equations in the literature and soil science for a long time that have been able to predict what we call plant available water. But there was this kind of mismatch that was going on where the research was saying, yeah, more soil organic carbon really doesn't seem to hold more water. But then we had growers, I've interviewed growers, and they're telling me, like, man, I can see that my field is not ponded when my neighbor's field is ponded. I can see that the greenness of my crops is a week later into a dry period than my neighbors. And I attribute it to the fact that I'm seeing my carbon levels go up, my soil organic matter being built up, and I'm seeing these things in the field, this physical relationship. So that data set was able to really validate what our growers were seeing, and it was able to do that for a couple of really important reasons. One of them we've already talked about, which was just that the study already included management at each site. So past studies mostly were just looking at, hey, a soil over here holds this much water, and if you go over there, it holds that much water. Well, that's not really a management change. A management change is, what actually did I do differently on the same soil type to get something to happen differently? So that management effect was really strong in this data set. And the other thing is that we used intact soil cores. We didn't pulverize them and then see, oh, what's the effect of this? And to me, that using those intact soil cores really allowed us to see how soil structure was changing, because these folks were not tilling as much as the controls were tilling. And so that really brought us this predictive equation, which we've published in the peer-reviewed literature, that shows that about twice as much water is being held because of changes in soil organic carbon as past research had shown. So we have these equations, we publish them so that everybody can go and use them. And one of the places that they've already been used is in the Comet Farm Tool that you mentioned. So the Comet Farm Tool has been around for a while. It was developed at Colorado State University with support and input from USDA NRCS. And it's a greenhouse gas accounting tool. So it's really helping growers to be able to go in and say, if you made some management changes and you did them for, let's say 10 years on your particular farm with your soil type, what would we end up with in terms of your reduction in greenhouse gas emissions? Another thing they're looking at is, hey, okay, that not only that, but how much more carbon could I store in my soil? Well, that was the perfect opportunity for us to apply these new equations that we had and say, you already know what the carbon is going to be when you change your management practices. Now let's talk about water. And so today in the Comet Farm Tool, you can go and run a simulation, and one of the tabs of your report is going to show you the change in plant available water. Now, that's pretty cool. That's good that you can see, hey, when I make a management change, I'm not just changing carbon, I'm also changing the plant available water. But to be frank, that's kind of like me telling you, okay, you've gotten a little bit bigger cup for water. And that's great, that's meaningful. But our growers know that when they're thinking about plant available water, they're thinking about not just, not a cup of water, but a cup for water. And what I mean by that is it's going to rain again and it's going to fill up again. And their crop's going to use that water, extra water, and it's going to rain again. And they're going to be able to really see that benefit multiple times throughout the year. So even though I might say, well, it's only 1/10 of an inch or maybe even less than that of plant available water holding capacity, that's not sounding really great. But if I start to say, well, in each rainfall, you might get another 1/10 of an inch. All of a sudden you can think, well, let me think back 2018, would that have mattered? 2019, how about 2020? And so, one of the other things we've talked about is that we're continuing this work now from the same equations to really think about that question that I just had, which is how does weather, local weather, maybe even more variable weather than we used to be seeing, how is that going to be able to inform the value that we get from increasing our soil carbon? It's not just the whole buzz around carbon markets, and it's not just the physics of having carbon there. Now we can quantify, hey, in the growing season, maybe you could get another 1/2 inch during, right before tassel. Would that be meaningful to you? So we're partnering with Cargill, who's supporting this work to really understand water stewardship of regenerative agriculture by hopefully creating decision support tools, maybe even a web app, where we can go in and have people interact with that and learn about how soil health improves plant available water over time.
Well, what really blew my mind when I was watching your video is in the example that you used there, it only increased the soil water or plant available soil water holding capacity by 1/4 of a 1/10. Okay. So 0.0025 of an inch. And everybody would be saying, so what? Big deal. Who cares? I'm thinking, wow, that's kind of disappointing here. I thought it increased it a whole bunch. But then when you talked about, yes, that increases it every rainfall or every irrigation event, you can hold 1/4 of a 1/10. Well, when you do that 4 times, well, you've delivered another 1/10 of an inch. And when you do it, let's say 8 times, you've given it 2/10. So, how many irrigation or rainfall events do we get in a growing season? There's quite a few. So that does, even though those little changes make a lot. And what I loved about that is you took a lot of existing big bodies, meta studies together into a practical, basically what if projection formula to show the true impacts to a farmer, that all of a sudden, if you show a person that and they can run it on their own land with their own soil types in there, they're like, oh, well, gee, that makes sense. I should look into this, right? That was the goal. And I think it's great for that. And thanks to you and the people at Colorado State, I believe you said, and everyone else that worked on that, because those are real data we can use instead of just, oh, gee, by golly, it looks greener, right?
Yeah, absolutely.
And that's going to be, okay, put the sociology hat back on. I was always told, I remember an internship I had in the summer in college, and a sales trainer came into a group of, hardened sales professionals, which means they're old, they've been there, they've done that, they know everything there is to know. And she told them that people buy emotionally and then justify their decision rationally. So I think the beautiful part about these type of tools is it provides that rational justification for that initial decision they make. Am I anywhere close on this? Do you agree with that?
Yeah, absolutely. I mean, I think there's this reality that, this is a complex decision, and it's not just based on one little thing.
Mhm.
And there's risk to be considered. And so our growers who are making changes, they may be thinking about the time that they're not spending on that tractor tilling that they're going to spend with their family. They may be thinking about the resilience for future generations. They may be thinking about a lot of different components. And so having a few tools that can help provide that justification, to your point, and also maybe show you when would it be valuable. And I think a lot of our philosophy here is saying, let's put the what if scenario in the grower's hands. I don't need to translate, inches of water to dollars for any grower out there. I can say, here's how many inches of water, and you can say, let me think about whether or not that's worth it. And today, I think increasingly the growers I speak to are also saying, might that be worth it if I have another year like I had last year? I work a lot in cotton soils, and I think of our growers in Texas last year and this year, and some of the landscapes that they were facing in terms of lack of rainfall and excessive temperatures. And when you're looking at those scenarios and saying, maybe my risk profile is not the same as it used to be. What more can I learn? What more can I have to understand? What tools do I have in my toolbox to influence this situation? And as to your point, that small amount that I may be able to increase the available water holding capacity of my soil, but I'm going to see it at every rain. Maybe that is enough. Maybe that is meaningful for me.
You mentioned cotton, and cotton's my favorite crop. But I've seen amazing things, especially in West Texas, where you have wheat stubble or cover crop stubble, strip till plant cotton. And, we get the rains, we get it drying out, and, it's in place. Where the neighbor did tillage, it's blown out. It's gone, just sheared off at the soil level from sandblasting, essentially. It's really amazing what those practices can do for the health of the plant. All right. Now, I think I kind of heard, and maybe I'm spoiling the fun here, but you can take these models because of the change in weather events that we're getting. So when we do get storms, we get them less frequently, we get them higher intensity. It seems to be in most areas. You can take, if that farmer can absorb and hold 1/10 of an inch more per rain event, now you can also probably predict runoff associated with that, and the ability of water quality that the farmer is exporting from the farm. Is that a stretch, or is that possible?
Yeah. No, I mean, it's certainly possible. I think that one of the things that we have to eventually be able to do is put all these components together in one place. And that's a struggle. A lot of the models that we have today, they were built asking the question, how does my soil affect my crop? In fact, I'd rather ignore soil if I could, but I guess I kind of have to pay attention to it a little bit.
You got to plant it somewhere, right? It's just
Right.
that pesky dirt out there.
Yeah.
It's just a place to hold a crop. And,
Yeah. And so a lot of the knowledge that we have today was built from that perspective. How does my soil affect my crop? And this may be a little bit over the line, but I honestly think we're in the first generation of kind of our mechanized agricultural societies that are asking, what can my crop do for my soil? I mean, certainly there have been indigenous cultures that have had that mindset for a long time. But if we think about, just the emphasis on cover crops and the idea that, wait a second, the purpose here is to change my soil, there's a lot going on there. And so when I say that all to say that I think there's a lot of work to be done on our models to really integrate all of this understanding of the components of when we change our management, how are we improving our soils, and how is that going to affect all the things that we were talking about, including, as you just said, there's eventually a tie to water quality, runoff, and things like our aggregate stability are going to influence How rough is our surface? Is that going to hold water a little bit longer? So putting all those things together is definitely the goal in the long run.
And the thing I love about these measurements you're talking about is these are very concrete measurements that are attainable relatively inexpensively, are very repeatable, are very certain, and those kind of things. And yet the industry or not the industry, everybody wants carbon, okay? And trying to concretely define where carbon's at in the soil, what form it's in, what pool. Is it a carbonate? Is it a humic substance, stable forms? What form is it in? There's all this flux, and what time did you take it? Moisture levels, crop rotations. It's just wild, isn't it, to try to predict carbon in the soil, where these other measurements are pretty that indicate the carbon, correct? So what I'm getting at is, do you think, rather than trying to chase this very moving target of exact carbon quantification, are we better in the carbon markets to be looking at the practices that drive these parameters, and we know those parameters then are associated with the carbon pool?
Yeah, that's a great question. There's so much there. And
we got a half an hour, so just take it.
All right, I'll dig in. No pun intended. So I think that, first of all, I'm supportive of any system that's going to provide financial benefits to our growers to do the practices that we know are good for the growers. They're good for the profitability. They're good for risk reduction. They're good for the environment. So I'll take any approach that I think will work us out there. But I do think we see a lot of folks recognizing just what you're saying, that we have these principles. We know that good things come from applying these principles to the best degree that we can in the system, and what practices make sense to do that. And then how do we measure progress? How do we measure progress towards that goal? And so that's where a lot of our measurement work has come in, is being able to try to have a minimum suite that we can say, okay, how good could you get? And let's measure you against a reasonable benchmark for your own system, for your own work. And our growers know that. You wouldn't compare yield across the country. Why would you compare soil health across the country? It doesn't really make sense. And I think there's a lot of diversity in terms of the payments for practices that are out there today. We have historic investments in climate smart commodities right now from the USDA. And I think you're going to see a lot of different approaches come across in those projects, a lot of diversity of thought in what makes sense to actually incentivize the growers for these practices. So I don't know that right now, today, that we have to pick. I do think it can be really costly to verify by measurement on the ground exactly how much carbon has changed in your soil. And especially if you're talking about like understanding it over space. A lot of times our measurements may be in a particular spot in a field, and it gives you an idea of directionally how are you going. But maybe I don't have to measure it exactly for every location in that field, because to your point, I'm not reporting exactly the 1 million metric tons of carbon dioxide equivalent that this field stored, but I am telling you that what you're doing is working and you're moving towards a reasonable reference state for your soil.
Yeah, that's a really good point. Comparing yourself to yourself, not to everybody, but always moving that benchmark up too. I mean, that's another component there. All right. So you mentioned briefly about the money that's out there, USDA, and then there's also a lot of companies that are interested in this too. And just recently, Soil Health Institute and Cargill announced a partnership, $3 million partnership or so to equip farmers. Share a little more about the intentions of that and how Soil Health Institute's involved.
Yeah, absolutely. So I think really the piece here that we're really honing in on is for the regenerative practices that Cargill growers are already working towards implementing on their farms. How can we really reliably quantify what the benefits look like in terms of that water component, that water stewardship piece? And so that's why we're bringing to bear the publications, the equations that we mentioned, to provide decision support for growers that takes what we've talked about that's available in comment today, but adds that additional layer of let's not just look at your farm, but let's also look at, when are we seeing these benefits? Is it going to be during drought years? Maybe that you're going to see that benefit. Is it during moderate years? Maybe it's going to be that it's actually during the wet years that you're going to see that benefit. And how often do we think that's going to occur? And is it going to be meaningful for your particular soil? Maybe you have multiple soil types. Maybe you have a clayey soil in one part of your farm and a sandy soil on another part of your farm, and you're interested in understanding, how might these practices capture water differently? So that's where that particular work with Cargill is focused, is on a water stewardship quantification, and developing decision support tools that are free and available to growers everywhere to be able to understand that better. And I think what it does is it provides, back to our conversations on that adoption decision, provides a little bit more information about how you're going to see things. You might see things change on your farm when you improve your soil carbon with these regenerative soil health management practices.
So why would Cargill want to do this?
Yeah, I mean, I think there's really wide recognition today from so many different groups that if we are going to be around in the long run and we're going to see increasing levels of supply chain risk, that we need to be thoughtful about having robust supply chains. And that starts at the farm. And it starts by making sure that our growers are equipped to manage these difficult weather years that we're having, and that they're able to do that with the best information at hand. So, this gets to something that I think now's a fantastic time to be a soil scientist. I think there's really understanding at a societal level that soil matters, that our environment, how we treat it comes back to us. And so I think that Cargill and many others are in this space of realizing that we do have to have risk reduction in place. And for us, for agriculture, risk reduction is really soil health in the long run.
So you mean to tell me they want bushels going through their terminals?
I think that's a piece of it, yeah.
That's a piece of it. And also, I mean, there's value add for everyone involved, right? For the grower, farmer, and for Cargill in having a higher, maybe a better carbon intensity score, or whatever the measurement might be that would add value to product that they're marketing. So plus they have their own benchmarks they need to meet as a corporation for their activities, correct? For carbon offsets.
Absolutely. I mean, I think that really when we look at these global goals that Cargill, that many others have as well, I think that it's the same narrative that we've been talking about at the farm scale, where we want to know what's reasonable, how can we achieve it, and then let's go ahead and set some goals and get some skin in the game to make sure that we're moving towards our goals and our progress. And so to me, this is a great example of that. And I'm excited because, as you mentioned earlier, there's so much interest in carbon, which is wonderful. I think that's a great thing, but we don't want to get tunnel vision. And to me, being able to tie those changes in practices that change our carbon, that then change our water dynamics, is refreshingly holistic. And I think that, that's the thing about soil health, is that it is so holistic. It's such a big picture thing, and it changes from place to place. I had a grower in West Texas telling me that everyone said, hey, you really need to grow cover crops. And he said, well, what really works super well for me is to have a high biomass crop in my rotation, so that I'm laying down enough cover, enough armor, that I have that in place for erosion protection, but maybe I don't have to lose the water that I might to a cover crop. And so what I realized in speaking with him is that he wasn't saying, I do like soil health or don't like soil health. He was really talking about a water limited system where he had trade-offs between soil health principles. One was producing armor, and one was having living roots in the soil. And in his particular situation, he needed to skew it a little more to that soil armor side and a little less to that living root side. And that makes perfect sense. Mm-hmm. And so I think, for all of us, resources are limited, and how we deploy these different practices is local. But it does require a big picture, holistic view. And I'm excited to see carbon linked to water, and being able to inform growers about how that links together and works.
But the reality is that grower that you're speaking of in West Texas didn't just keep doing the same thing that he'd always done because he'd always done it. Correct?
Absolutely.
Isn't that the greatest hope, is that everyone's trying something? And if you're listening to this, you need to be trying something different. And you don't have to change the whole farm at once, but you need to try a couple different approaches to learn how you can be better equipped to meet these market needs, right? So it's not only the needs that you have on your farm, but it's needs for the market. You should always be trying something. Do you agree with that?
Yeah, absolutely. I mean, I think that starting small, understanding maybe there's a local person who has some experience. When we think about farmer education, grower education, we don't parachute in someone with a PhD in soil science from another part of the country and say, hey, why don't you go tell folks what they should be up to? We always have the foundation of local technical specialists and farmer mentors who understand those systems. And you're exactly right. Those are the folks who are innovating out there, who are trying something new. Maybe you try something on a split trial, try something in that backfield that you has a problem with something. And one of our soil health educators was fond of saying, don't tell me you're going to plant cover crops, tell me what problem you're going to solve. And I think that's the approach to have. Why am I doing this? What am I needing to change? And so I really agree that being able to experiment, being able to learn what works for you, taking what others have said, and maybe stepping out a little bit to learn what works for your farm is an approach that I think our most successful growers will tell you has worked for them.
And I think neighbors working together too can be a good resource where one tries one practice, one tries another, or you both try the same practice and share notes and learn from each other, because it's not a competitive spirited thing. This is learning what we can to save a resource for family generations to come. So it was interesting. I did visualize there's probably some of those people you'd want to parachute in and not give them the parachute, just give them about the air. No, anyway,
No comment.
You get these weird visualizations as you're talking. But you did mention what problem are you going to solve with the cover crops? I'm going to turn it to you. What problem are you going to solve? What do you see in your career? If there was some problems that you definitely wanted to solve, what do you want those to be?
Yeah, absolutely. Well, this project that we've been talking about today, really being able to provide robust visualizations for the amount of water that we can store when we increase our soil carbon with soil health management practices, is something that, as a native Texan, as someone from a water limited environment, and having done interviews with a lot of farmers in my graduate work who were telling me this is what we're seeing on the landscape. And I don't know why it's happening, but I know it's happening. When I go to soil health, I'm seeing these benefits. Being able to bring that to bear in these next 3 years on this project is really exciting to me. I think the other thing in the long run that I really, many of us at the Soil Health Institute are focused on is providing those reasonable local benchmarks to be able to say, hey, this is about how good your soil could be. And this is how well the folks are doing in your area. Why don't you see if you can go out and get that, so that we are not, comparing apples to oranges, but we're really providing you something locally in a benchmark for your soil health that makes sense. And then we've actually kind of talked about the third thing that, to me, in my long-term career, I'd love to see is I'd love to be able to capture enough about how these soil health systems work to represent them in models. So many of our models really are from a different time, or they don't have robust soil health management systems depicted in them, because when the models were created, people weren't using those practices. They weren't even necessarily around and well represented enough to get the data. And so this project is also a little step towards that, being able to capture a process and say, guess what, guys, this looks totally different. The physics have changed when we're in a soil health management system. Let's make sure we can predict that.
And you mentioned a data set of 124, I believe, sites or so in North America, so including Mexico and Canada and probably Central America, to get all that site data involved. Seems like a lot, but when you think about it, for all the other product-based research we do, the 3-year trials to prove a product right, that's just minuscule. So having the robust data set to work on these long-term rotations where there's nobody paying the bill because it doesn't sell more of XYZ, that's a real problem, isn't it?
It can be, yeah. I think definitely, especially when we think about soil health management systems, data availability is a big piece of the puzzle. And, one of the ways we are addressing that right now is when I talk about these benchmarks and we're out sampling benchmarks, we're doing that on growers' fields, because those are the folks who actually have it happening. And we'd always like to see higher adoption numbers going out there, but I think we're seeing more and more folks who they understand that this is where the future is in these regenerative practices.
I agree with you completely. I think a lot of these system-based observations need to be made at the farm level, because first off, you have the reality of larger equipment, actual farming practices and such. A good friend of mine says farmers are not good researchers and researchers are not good farmers. So the two need to stay in their lane and and do what they do, right? But how do you the only problem I see with that is you bring everybody up to the best benchmark of what's today. But how do we make the best better? Which I think there's lots of room for growth, and where maybe the best benchmark in the neighborhood is. There's a lot of cases where I don't think 2x is out of the realm of being able to be achieved. So how do you, the problem is then you create a whole bunch of sample points to get to, today's best. How do you do that on farm and encourage that benchmarking studies within the climate context to get them to their next level of soil health benefits?
Yeah, absolutely. That is I'm so glad you asked that question, because we're really getting into the experimental design of how we think about these benchmarks.
Mhm.
So we're going to a space, and maybe we're interested in representing cotton growing acres in, say, the Blackland prairies of Texas. So those are our shrink swell soils in Texas, a lot of cotton production on them. So we want to stay on the right soil type. We want to stay in the right region. We're going to sample those growers who they haven't really adopted anything new. And we're going to sample those who maybe these guys are really pushing the envelope for where they are. But we're also going to sample a third system. We're going to look for something that's in a perennial vegetation, something that really maxes out our soil health principles. And, some folks will say, well, how is that a fair benchmark? I can't keep a perennial system on my cotton acres all year round. But it does exactly what you just were speaking about, is that it gives you the logical maximum for your soil type, for this rainfall regime, for this environment. And so now we're able to say, yeah, you might not quite get there, but now we have this upper limit for you, and we're not comparing you to somebody in Iowa and what they were up to. We're comparing you to something local, and we're saying, here's now the room for improvement. And what's amazing is that we see growers, even in places where there's not a whole lot of adoption, we'll still find one or two growers are achieving their benchmarks for their soils, for their soil texture, for their region. And so that tells me that you're exactly right. We can do more than what's out there. I don't think we know how exactly the combination of practices that's going to make soils the most healthy. I think there's a lot more to be learned there. But we can get an idea of how much carbon that soil could store, how strong those aggregates could be if we look at a soil that maybe it's under, and you don't find this in every scenario, but I've sampled beautiful native prairie vegetation in parts of Texas where, man, I was like, this is a soil organic carbon value of 4. I didn't even know this existed in this soil type, but it's gorgeous and it's there. There were a lot of chiggers there too, which were less gorgeous, but hey, anyway, I digress. I think these are the ways that we can provide those benchmarks that are local and still recognize that our growers are probably going to innovate past what they have been today.
You heard it here. What you need to do is seed chiggers into your field to attain high organic matter levels.
I think I left some
right?
organic matter there too.
Well, back to those shrink swell soils, those black shrink swell soils. I mean, boy, if you farm those and you start implementing no-till and cover crops, or get some winter grains into that, what a difference. I mean, that right there doesn't require a lot of high-tech instrumentation, does it? I mean, that is what I like to call a Ray Charles moment. A difference so big, even Ray Charles can see it. So, when you go for those 2-inch wide cracks and those vertisols to, a 1/2-inch wide crack, that's a big deal, isn't it? You've probably seen that.
Yeah, I mean, those were the soils that I really learned soil science on, which, is like saving the hardest, starting at the hardest spot, I guess.
I was going to say, your professor didn't like you. What
well,
man, what'd you do to him or her?
I can't speak about that on a podcast.
Oh, okay. That's safe.
But I'll say, I think that were those systems and those water limited systems. And I'll tell you, I tried infiltration measurements on a soil that had just been, tilled the heck out of. And truly, I was like, I can't measure infiltration on this because it's so little is seeping into the ground that it's
You
just like
had to
concrete.
hit a crack. You had to hit one of those cracks. That's how they recharge.
That's right. That's right. And then, I'd be on this absolute same soil type across the fence, and I'd see someone who they've been doing no-till and cover crops for 21 years and we're so thoughtful about it. And man, you just see that those infiltration rates, those recharge rates go up. And if, to me, being able to observe that is something that I'm really blessed to have been able to have the opportunity to do and understand these practices. When we go back and we observe those principles as the best we can in the space, we really get to see a difference.
Well, that neighbor got more rain, don't you know?
Of course.
Yeah. But, or you had better irrigation water. But in the case of you probably on some of those tests would lose more to evaporation than you would to infiltration. You have to be careful on the time you spent doing that, right?
Yeah, no doubt, in a hot day in Texas.
Yeah. All right. So that is a great foundational thing. What else should we have visited about while we had our time here together today?
Yeah, absolutely. I mean, we've covered so much. I think we've really gotten it. One of the questions that came to my mind is, a colleague of yours mentioned, what do you want to see change? What do you wish was not, what are you afraid might stay the same? And I think we've hit on it before, but just realizing that our supply chains, our environments are they're in this rapid change. And I think it's about, what do I not want to stay the same? Well, I don't want to keep doing the same practices, and I don't want to take the same research approaches, and that we always have. It's the if nothing changes saying. And so we're in an opportunity where I think we have unparalleled investment from the USDA. We have unparalleled interest from society, from supply chains, from corporations, all saying we recognize that we need to be able to measure progress towards real goals that provide society and the environment the stability that they're going to need. And so I hope we don't waste it. I hope that we find a way to work together, that we find a way to share the benefits and not saddle any one group of people with all the work to get this done, and that we find a way to be collaborative, as you've already spoken about, and make sure that we're able to share what we learn and make a better place for everybody to live.
You make a great point with all those changes that are going on with society and business and government, all these things coming our way. I think as farmers, we need to ask ourselves the rate of change that we see around us, whether it's in technology, phones, cars, everything there, whether it's in, all the regulation side and opportunity side, really, with all these additional subsidies, carbon credits, those kind of things. I mean, it's just constant barrage of change. And that is accelerating. Are we doing the same in our practices? How rapid are we changing and adopting our farming practices in comparison to the rest of the world around us? And I would contend that we are nowhere close to the rate of change. Now, I don't think you should change just for the sake of change, but you have to realize that this isn't the way it was 40 years ago. We have to be adopting and getting better all the time at a faster rate. And I hope with what you're doing and the entire team at Soil Health Institute is going to really help farmers get the information and knowledge they need, plus the benchmarking capabilities, which I love, that will validate the changes that they're making and can adopt and make changes at a faster pace. Don't you think that's really what needs to happen?
Yeah, absolutely. And I think the other thing about, taking a quantitative, thoughtful approach to it is then, we can show that good is being done there. And not only, and you kind of get credit for it, you say, hey, this is how I'm doing on my farm and what I'm doing to move forward and to approach that benchmark. And we know that from our economic analyses that growers who do that are more profitable. Those folks trying new things are the ones who are seeing those really high benefits in terms of savings, as well as in terms of increased income. And so I firmly believe that those who, really do get behind this and learn what works for them, maybe take it slow, but who arrive at the changes they need to make on their properties, they're going to be the folks who are there in 10 years telling us how they did it.
Then if you're more profitable, you got those tax problems and accountants, and I'm not sure
Well,
that.
I can't say I know anything about that. That's something I'm fortunate to not have to worry about as a scientist.
Well, it could be another discipline for you. But no, thank you so much. I really appreciate your thoughts and the work that you're doing and the entire team's doing of bringing everything together in a thoughtful manner. And It's great to see that, Dianna.
Well, thanks for the time. I sure enjoyed it.
Well, I wish you the best in your continued pursuit of seeing how all those things work together. And I'm guessing, I can just tell by the fire and the passion here, that we'll be visiting again in the future and get an update on how things are going. So I look forward to visiting with you again in a few years.
Me too.
All right. Take care, Dianna.
Mhm.
We are truly grateful that you continue to tune in. It's guests like Dianna with their unwavering commitment and innovative approach to soil health assessment that are paving the way for more of these regenerative practices. And if you're curious to learn more about our efforts in equipping growers to lead the charge in implementing soil health practices, check out our website at asn.farm. And there you can click on links to follow us on Facebook, Twitter, Instagram, LinkedIn, and YouTube. There's a lot of great things happening and always something to learn. Thanks for listening.